So the way that I would approach the domain and range is the same as I would approach this entire problem. Just I would sketch what you have. And now, if you want to enter this on your calculator, and I'll show you what that looks like here in just a moment, but you can. But it should be just as easy to sketch it. These are all the transformation rules. We've talked about them with a bunch of different kinds of equations. And so if we look at this, remember, here is our basic graph. We're looking at a square root. So first, if you imagine, here's the basic parent graph that we're basing this on. And now what we're going to do with this parent graph is we're going to shift it vertically up 1. So this point right here is the point that we're going to be moving. So we're going to move that point up 1. Okay, that's the plus 1. So this moves up 1. Okay, this portion moves it horizontally. Is it going to move it to the right or left? Moves it to the right 5, right? It moves it to whatever value x would have to be to make it this whole expression equal to 0. So if x is 5, this expression is 0, so plus 5 means 1, 2, 3, 4, 5. So this point I can now plot. I know this is going to be my left endpoint. So right now I know that information. Okay. I also, just from here, I know that my domain is going to be everything that's greater than or equal to 5. Okay. But if I look at the rest of my graph, this negative part tells me that I'm going to reflect it. And the only reflection that we're talking about is a reflection across the x-axis, a vertical reflection. So this graph that did open up and to the right is now going to open down and to the right. And then the final thing that plays a role is this number 4, because it reflects across the x-axis. It's going to reflect vertically. So it's going to take this graph and it's going to mirror it down here. And then the final thing is this, the number. Again, regardless of whether it's a positive or a negative, you can decide whether it's going to stretch or shrink your graph. If this number is greater than 1, it stretches it. If it's a fraction that's smaller than 1, it shrinks it. So this is going to stretch your graph. So it's going to open down. It's going to be, again, I exaggerated it a little bit, but it's going to be, it's going to open more dramatically than our parent function. So this is what our graph should look like. For this, the domain, all the x values, it's everything. You need to identify what is your lowest x value and what is your highest x value. So for a problem like this, when you're looking at the lowest, you get what? The lowest x is 5. The highest x is infinity. Okay, you can never include infinity. And in this particular case, you have a bracket at the 5. Okay.
So is it better to draw it out or should just like think about it?
I would, yeah, I'd sketch it out. It's easier to see it. Okay, now your range, and this is the one that'll vary a little bit, because all of your square roots, the way that we've done it, because we're not really dealing with any where there's a negative inside the function, that's the only way it would open to the left. So our graphs are either going to open up and to the right or down and to the right for square roots, okay, which means your domain is always going to be whatever this horizontal shift is as your lower limit, and infinity is your upper limit. Now the range can flip, though, because it's either going to open up or it's going to open down. So in this case, it opens down. So you need to do the same thing. You need to figure out what's your smallest or your lowest y value. The lowest you can possibly go along the y's is negative infinity, but it's infinity in the negative direction. And then the highest it can possibly go is to this 1. Okay, it includes 1, does not include the infinity, so those would be your domain and range for that.